Hello and welcome to episode 11 of Random Topics with Jack, the podcast where we explore the intriguing and sometimes controversial topics that shape our understanding of the world. Last time we delved into the fascinating relationship between music and mathematics, discovering how harmony and rhythm are built on complex mathematical principles. But this week we're going to warp things up a little bit. So get ready to bend your mind because we're diving into the Alcubierre Drive, a theoretical concept that could potentially make faster than light travel a reality. Think of it as a shortcut through the fabric of space-time itself. It's a concept that's both mind-blowing and potentially revolutionary. Let's get started. So the Alcubierre Drive is a speculative idea that suggests a method for achieving apparent faster-than-light travel by warping space. This concept was proposed by Miguel Alcubierre, a Mexican theoretical physicist, in 1994. Miguel Alcubierre was born on the 28th of March 1964 in Mexico City, Mexico. He earned his PhD in physics from Cardiff University in 1994, focusing on numerical relativity, a field that combines general relativity with computational techniques. His research delved into the behaviour of gravitational fields and the dynamics of spacetime. Alcubierre's proposal for the Alcubierre Drive emerged from his desire to explore the possibilities of faster-than-light or FTL travel, a concept that has captivated scientists and science fiction enthusiasts alike. His work was significant because it provided a theoretical framework that suggested FTL might not be entirely impossible, at least within the laws of physics as we understand them. So the Alcubierre Drive operates on the principle of manipulating the fabric of spacetime itself. Instead of moving a spacecraft through space, the drive would expand space behind the spacecraft and contract space in front of it. This creates a wave of warped space that the spacecraft rides. The spacecraft would be contained within a warp bubble. In this bubble, the laws of physics would remain normal, allowing the spacecraft to operate as it would in regular space. However, the bubble itself would move through space at superluminal speeds. And while the concept is theoretically intriguing, it does come with significant challenges, particularly regarding the energy required to create and maintain such a warp bubble. Initial calculations suggested it would require an enormous amount of negative energy or exotic matter, both of which have not yet been discovered or created. However, if realised, the Alcubierre Drive could revolutionise space travel, allowing humanity to explore distant stars and galaxies in a fraction of the time it would take using conventional propulsion methods. In summary, the Alcubierre Drive presents a fascinating theoretical approach to overcoming the limitations of light speed travel by warping spacetime. While it remains a speculative concept, it continues to inspire both scientific inquiry and imaginative storytelling in the realm of science fiction. The Alcubierre Drive is rooted in the principles of general relativity, Einstein's theory of gravity. General relativity describes gravity not as a force, but as a curvature of spacetime, caused by the presence of mass and energy. The Alcubierre Drive proposes to exploit this curvature by creating a warp bubble that distorts spacetime. This bubble would essentially push the space behind the aircraft while pulling the space in front of it, creating a wave of warped spacetime. So if you imagine a sheet stretched taut, if you place a heavy object on it, the sheet will bend. This bending represents the curvature of spacetime. The Alcubierre Drive aims to create a similar bend in spacetime but on a much larger scale, allowing the spacecraft to travel faster than light. Now, one of the major hurdles in realising the Alcubierre Drive is the requirement for negative energy. This exotic form of energy, unlike the familiar positive energy we experience in our everyday lives, possesses a negative mass energy density. While negative energy has been predicted by quantum field theory, it has not yet been observed or created in a lab setting. The Alcubierre Drive relies on this negative energy to create and sustain the warp bubble, as it is needed to warp the spacetime in the desired way. Now, the Alcubierre Drive faces numerous challenges and criticisms, making its feasibility highly questionable. As mentioned, the drive requires negative energy, which is currently theoretical and has not been observed or created. But the energy density required for this bubble is immense, making it a significant obstacle. And even if it were available, the amount needed to create and sustain a warp bubble would be astronomically high, exceeding our current energy production capabilities by many orders of magnitude. The stability and control of the warp bubble remain uncertain. Maintaining a stable warp bubble would require precise control over the distribution of negative energy, which is a significant technical challenge. And then you've also got the Casimir effect, a quantum phenomenon that produces negative energy between closely spaced plates. This has been proposed as a potential source of negative energy for the Alcubierre Drive. However, the energy produced by the Casimir effect is extremely small, making it impractical for creating a warp bubble. Some physicists argue that the Alcubierre Drive could violate the principle of causality, which states that an effect cannot precede its cause. The drive could potentially allow for time travel, which raises complex philosophical and physical implications. And while the Alcubierre Drive remains a fascinating theoretical concept, its feasibility remains highly uncertain. The challenges associated with negative energy requirements, and potential causality violations make it a distant prospect. However, ongoing research into exotic matter, quantum field theory, and advanced propulsion systems could shed light on the potential of the drive, even if it is not achievable in the near future. It continues to inspire scientific inquiry and imagination, pushing the boundaries of our understanding of space and time. The concept of the Alcubierre Drive has inspired many numerous works in science fiction, showcasing its potential to capture the imagination of writers and filmmakers alike. Some notable examples are the iconic warp drive in Star Trek is a direct nod to the faster-than-light travel, allowing starships to travel vast distances in the galaxy. And while not explicitly using the Alcubierre Drive, the film Interstellar explores the concept of space-time manipulation and gravitational effects, echoing the themes from Alcubierre's theories. This series, The Expanse, incorporates realistic physics and touches on the challenges of space travel, often referencing theoretical concepts like the Alcubierre Drive. The book The Forever War by Joe Hadelman. This novel features FTL travel and explores the implication of time dilation, a concept closely related to the ideas behind the Alcubierre Drive. Revelation Space by Alistair Reynolds is a series of books that includes advanced propulsion technologies, including concepts reminiscent of the Alcubierre Drive, highlighting the allure of FTL travel in speculative fiction. But then there's also video games. Elite Dangerous is a space exploration game that allows players to use FTL travel mechanics that are inspired by real scientific theories, including the Alcubierre Drive. And Starship Simulator, which is currently in development by Fleetyard Studios, is a game which features the Magellan class starship, which utilises the Alcubierre Drive. And for anyone interested, the demo on Steam is highly recommended by myself. It's very interesting. It takes a very innovative approach to space travel because you are part of the crew. You're an engineer or you're on the ship. It's a great game. I definitely recommend checking it out. The allure of faster-than-light travel, though, has sparked significant public interest, but it also comes with a host of misconceptions. Misconception 1. FTL travel is possible now. Many people believe that FTL travel is just around the corner due to its frequent portrayal in media. In reality, while the Alcubierre Drive is a fascinating theoretical concept, it remains speculative and faces numerous scientific challenges. Misconception number 2. FTL travel means instantaneous travel. Some people think that travelling faster than light would allow for instantaneous travel between 2 points. However, even if FTL were possible, it would still involve complex physics and potential time dilation effects. Misconception number 3. FTL violates physics. While the Alcubierre Drive operates within the framework of general relativity, Many people mistakenly believe that any form of FTL is impossible. In fact, the drive proposes a method that theoretically circumvents the light speed limit by warping spacetime. And misconception number 4, all FTL concepts are the same. Not all FTL concepts are created equal. The Alcubierre Drive is just one of many theoretical models, each with its own set of challenges and implications. So the Alcubierre Drive has not only influenced a wide array of science fiction, but has also ignited public curiosity about the possibilities of space travel. While the concept remains theoretical, it continues to inspire both scientific inquiry and imaginative storytelling. And there's also been some recent studies and advancements on FTL travel, such as APL's summary study. Warp drives may actually be impossible someday. The study offers a theoretical framework suggesting that warp drives could be feasible. It discusses the mathematical models that support the existence of warp bubbles and explores the energy requirements needed to create and sustain such bubbles. The researchers emphasise that while significant challenges remain, the concept is not purely science fiction. Eric Lentz and colleagues done some research as well, which introduces a warp drive model that operates within the confines of known physics, particularly focusing on the manipulation of space-time using negative energy. The paper details how this model could theoretically allow for faster-than-light travel without violating physics, making it a significant contribution within the field. Harold White and his team done a groundbreaking study outlining a new design for a warp drive that could potentially reduce the energy requirements significantly. Researchers conducted simulations to demonstrate how their design could create a stable warp bubble, discussing the implications for future spacecraft and interstellar travel. A team from the Open Journal of Astrophysics studied they simulated the gravitational waves emitted by a warp drive in the event of a failure. Researchers used advanced computational models to predict the characteristics of these waves, which could provide insight into the potential risks and consequences of operating such technology. The findings could also help in detecting warp drive failures in future missions. Various researchers have done studies which model the breakdown of hypothetical alien spaceships using warp drive technology. By analysing the gravitational wave emissions generated during such breakdowns, the researchers aim to understand the physical phenomena involved and how they could be detected by current gravitational wave observatories. There's also a paper that provides a comprehensive review of the Alcubierre warp drive metric, explaining the fundamental principles behind warp field mechanics. It discusses the theoretical underpinnings of warp drives and outlines the challenges faced in practical applications, serving as an educational resource for those interested in the physics of faster-than-light travel. Some notable people who are working on FTL, as we mentioned, Eric Lentz, who described a method for creating warp drives sourced from known and familiar positive energy, contributing significantly to the theoretical framework of warp technology. Harold White is a DARPA-refunded researcher at the Limitless Space Institute. White has claimed to have succeeded in creating a real warp bubble, marking a significant milestone in warp drive research. The aforementioned APL, Advanced Propulsion Laboratory, is an institution at the forefront of unravelling the mysteries of physics through warp field mechanics, conducting cutting-edge research in the field. The University of Alabama in Huntsville, UAH, researchers there have published papers demonstrating the feasibility of subliminal warp drives, contributing to the growing body of knowledge in warp technologies. The space agencies, while warp drive is still in its early stages, it's likely that space agencies like NASA, ESA, CNSA are closely monitoring the developments in this field. These agencies are always seeking to innovate seeking innovative ways to advance space exploration, and warp drive technology, if feasible, could revolutionise our understanding of the universe and our ability to travel beyond the solar system. The field of warp drive research is rapidly evolving, with numerous studies and innovative theories emerging. These advancements not only enhance our understanding of theoretical physics, but also inspire hope for the future of interstellar travel. The potential involvement of space agencies in this research is a testament to the growing interest and potential impact of this technology. We'll look at some of the future implications of the drive, of FTL travel in general, and it's one of them is revolutionising space travel. It'll give us more accessibility to the cosmos. Warp drive technology would make the universe accessible to humanity in a way we've never imagined. Imagine travelling to distant galaxies, exploring exoplanets, and witnessing cosmic events like supernova firsthand. This would revolutionise our understanding of the universe and inspire new scientific discoveries. The concept of distance would also become less relevant as warp drive technology allows us to traverse vast distances in a fraction of the time it currently takes. We could even explore the possibility of time travel, though this still remains even more speculative. In the pursuit of warp drive technology would drive advancements in fields like theoretical physics, materials science, and energy production. The challenges of creating a warp bubble would force us to push the boundaries of our current understanding of physics, potentially leading to unexpected breakthroughs. Another implication is interstellar colonization. Warp drive technology would enable humanity to colonize other planets and star systems, creating a multiplanetary civilization. This would offer a backup plan for our species in the face of threats like climate change and asteroid impacts. The ability to travel between star systems could lead to interplanetary trade and cooperation, fostering a more interconnected and diverse human civilization. But the potential for interstellar colonization raises ethical questions about our responsibilities towards other planets and potential extraterrestrial life forms. How do we approach the colonization of new worlds ethically and sustainably? Another thing is scientific advancements. Warp drive technology would provide us with a unique vantage point to observe the universe, allowing us to study distant galaxies, black holes, and other celestial objects in unprecedented detail. The ability to travel faster than light would also revolutionise our understanding of the universe by allowing us to explore the early universe and test theories about the Big Bang. The pursuit of warp drive technology could lead to unexpected discoveries in fields like quantum physics, gravitational waves, and dark matter. The involvement of space agencies in warp drive research could lead to increased funding and resources dedicated to this field. This would accelerate research and development, bringing us closer to practical applications of warp technology. For example, NASA has previously set up the White Judy Warp Field Interferometer to test warp field theories, showcasing their commitment to exploring this frontier. The complexity of developing warp drive technology may also foster international collaboration among space agencies, leading to shared knowledge and resources. This could unite countries in a common goal of exploring the cosmos, promoting peace and cooperation. As space agencies engage in warp drive research, public interest in space exploration could surge, leading to greater support for funding and educational initiatives. This could inspire a new generation of scientists and engineers. But we also have some ethical considerations to consider. The development of warp drive technology raises ethical concerns regarding its potential misuse. For instance, if such technologies were weaponized, it could lead to unprecedented destruction. Ensuring that this technology is only used for peaceful purposes will be crucial. And as humanity expands into space, we must consider the impact on extraterrestrial ecosystems. Ethical questions arise about our responsibility to protect potential life forms and environments in other planets. And if warp drive technology does indeed allow for time travel or time manipulation, it raises complex ethical dilemmas regarding the consequences of altering timelines. The implications of time dilation on human experience and societal structures would need careful consideration. So, the successful development for the Alcubierre Drive could usher in a new era for humanity, transforming our approach to space exploration and colonization. However, it also necessitates a thoughtful examination of the ethical implications and responsibilities that come with such a powerful technology. So we've explored the fascinating possibilities and challenges of the Alcubierre Drive, but what are your thoughts? Do you think warp drive technology is a realistic possibility? What are the implications of the Alcubierre Drive that excite you the most? Are there any ethical concerns that you have about this technology that we've not already mentioned? Let's spark a discussion. Share your thoughts and questions, and I would love to hear from you. This technology is truly mind bending, and I'm eager to hear your perspectives. So, today we've delved into the fascinating concept of the Alcubierre Drive, the theoretical method for FTL travel. We've explored its potential to revolutionise space travel, allowing us to reach distant stars and galaxies in a fraction of the time it currently takes. And we've also considered the ethical implications of such technology and the challenges of making it a reality. From the groundbreaking work of Miguel Alcubierre to the potential for interstellar colonisation, we've journeyed through the possibilities and complexities of warp drive. We've even considered the potential impact of space agencies getting involved in this research. But the journey doesn't end here. The universe is full of mysteries, and we are just scratching the surface. And next time, we'll be diving into the world of sleep. Get ready to explore the science of sleep and uncover the secrets of this essential human function. We'll be exploring the mysteries of sleep, its role in health and well-being, and the impact of sleep disorders. So don't let the night slip away. Join us next time for a deep dive in the world of dreams. And as always, I've been your host, Jack, and until next time, keep questioning and exploring.